Welcome to Ghost Likes channel. I am your AI assistant for the day, Vilo. In the previous video, we created a basic login page and thoroughly covered the path leading up to it. Now it's time for part 2. We had time to think what we want to do in this video, and our main goal should not be to move to ASP.NET Core Identity or to bring in the fancier databases than the in-memory one that we are using, but instead to set up third-party authentication using the Microsoft Identity Platform. So that will be the main goal of this video. We'll clean up after that. Let us get started. We have our main goal set, but before we tackle it, let us do a little side quest. We did something yesterday that we should have covered, but didn't. We are talking about this challenge async. In addition to the sign in and sign out, the authentication middleware has challenge and forbid. So it stands to reason that if we require the user to log in, we should use the relevant status code and the functionality intended for it. The way we had it previously here would have led to the challenge being overwritten by a regular redirect. Let's try running it and see what happens now if we try to access the user page. We got rid of the cookie earlier, so we aren't logged in currently. As you can see, after we issue a challenge, a redirect happens, but to the default login path for the cookie schema and not the one we've made. What we will do is change the defaults during the middleware setup. In the cookie middleware, you'll see that we can set the paths for login amongst the options. We'll leave the return URL as is, but it should be possible to get rid of it by setting it to null here. Anyway, that takes care of the side quest. We've cleaned things up a bit, and now we'll move forward towards our main goal. We'll start work on setting up passwordless logins using the Microsoft Identity Platform. Before we start, let us sketch out the request workflow using third-party authorization. It is different than the first-party one. Initially, the user connects to the web app where it is hosted on the internet. He sends the request, and instead of being prompted for his credentials right off the bat, the server instead redirects him to some third-party site. In this video, we'll be covering Azure Active Directory, but all these services work similarly. Anyway, the user will connect to such a service, get prompted for his credentials, and send it there. Assuming they are right, he will get redirected back to the original site along with an access token. And this access token is what will be used for authentication at the original site. What we will be doing here shouldn't be too complicated in theory, but it remains to be seen how we will manage it in practice. We'll start off by creating a new project in the solution with the goal of making Azure AD authentication work with it. We could try plugging third-party authentication into the project we've been working on before, but even if the C# template itself is easy enough to set up, how exactly will we do anything with it? The C# template itself, much like most ASP.NET samples you'll find online, has the clarity of a config file, and absolutely nothing is obvious. Nothing we've done before gives us any guide on how to proceed and integrate Azure AD into our own application. For that reason, all the work that we've done before is actually a burden. It would be far simpler to start with an application that only has an index page and then find a way to make Azure AD work with that. In the previous application, we had to make the login and the register pages, otherwise we wouldn't have any way to get the user data, but here we only need to redirect the user to the Microsoft site and get the token back from it. This situation is very stressful as we are looking up at a mountain, but can't see a path to travel it, so by paring things down to the minimum we will get rid of all the unnecessary factors. We do not want to be thinking about how to integrate the new with the old until we make a breakthrough needed to clarify things. Now, what should we do next? We mentioned a C# template, so let's set up one from scratch as an exercise. This will demonstrate to us how Azure AD could be set up as well. In fact, why don't we do it in the same solution as the F# projects? No reason why we couldn't do that. If we look at the Azure AD record values here, we'll see a couple of fields. The tenant ID is linked to your Azure account, so it needs to be there, and the client ID is linked to the application registration that we'll be creating on Azure Active Directory. So these two values need to be filled. The callback path is also important as it will get appended to the return URL. The domain and the instance, on the other hand, are not crucial. We tried various values for the instance, and based on that experimentation we figured that any valid URL address should suffice. The domain, on the other hand, we can just get rid of outright. It was convenient of Writer to offer us a way to automate the app registration on Azure AD, but we'll do it manually to show how it is done. We see the tenant ID here. We'll paste it into the relevant field in the JSON file. What we need to do after that is to go into app registration and create a new registration there. And amongst the values here, we see the tenant ID and the client ID. We already have the former, so we'll paste the later into the config file as well. And as we mentioned, we don't need the domain. Here we are trying to run the wrong project and backtracking. We also forgot to put in the allowed URIs, but just for demonstration purposes, let us try without that so we can see what errors do we get. That weird language you see on the screen is Croatian, but the error is in English. It says that some token is not enabled for the application, and in fact we missed that during the configuration. We'll toggle them on and go back to the page and try refreshing. That just shows us the same error page again though. We need to try it from the local host URL instead. The problem we have now is that we forgot to add the local host URL to the allowed URLs list, so let us do that as well. We'll do that, save, and try again. Refresh won't work, we need to do it from the localhost URL. And now that we have done all this, we logged in successfully. We won't show you the logout as it would be annoying to log back into our Microsoft account again, but if we run the browser in incognito mode, we'll see what the login screen looks like. If you squint closely at the URL, you'll see that the redirect URI is in fact a part of it. This is what will allow the Azure AD server to send the browser back to our own web application. The hard part to understand is, where do we get that address to the Azure AD server? It was one thing to redirect to our own login page in our previous project, but that URL that we saw was a real beast. To be honest, this clouded our mind for a while, until we came up with a conjecture. We'll test it out to see if it is right. First, let's add the necessary packages. Adding those will be a lot simpler now that we have the C# project inside the same solution as the others. Our plan here to start things off is to plug in the relevant services from the C# project. To do that we need to import the relevant packages first, and then we will let the ID guide us from there. Anyway, while that is being done in the background, let us explain what we want to try out. It is simple. Since we don't have any leads how this should work, what we will do is try the simplest possible thing, which is challenge async. Right now, using the challenge operation is the only way we can think of how to interact with the Microsoft Identity Platform, and we will be very confused if that turns out to be false. Assuming it works, we'll figure out what to do with the Azure AD's response after that. Similarly to how it was done in the previous project, we'll create a handler for the index page and make use of challenge async there. And with that out of the way, let's see what running this gets us. We are looking at this, and it is not what we expected, but it is not a complete failure as it is in fact getting sent to the Azure AD authentication page. We see that the page in the browser is constantly getting reloaded, which leads us to believe that it is an infinite request-response loop. Also, it is concerning that in the terminal it says that the token and the code is empty. We'll deal with both of these in turn. What we were expecting that the return URL would redirect it to the sign-in OIDC, which would show the 404 page, but to start things off, let us see if we can get rid of that infinite loop somehow. Since it is redirecting to the index page instead of where we expected based what was written in the return URI, let's just try authenticating before issuing a challenge. If it passes, we'll have the server show the index page. Will things be better this time around? Let's run it again. Yeah, it works. We've got it. If you found this video useful, please like and subscribe. Now, we are not really concerned about those empty token messages that we saw in the terminal. If they were really errors, the authentication wouldn't have worked. What we find weird is why isn't the redirect working as expected? Let us investigate why that is happening. Also before that, let's run the program with a debugger so we can see whether there is an email in the user claim somewhere. Rather than just show a generic login, we should address the user directly. It seems the claims principal has all kinds of data from the successful login. By the way, we've realized this too late, but it turns out it is possible to debug through the IIS proxy server. We keep selecting the HTTP one, and it is unnecessary for debugging purposes. If anything, we are surprised that the login still works despite the ports being different from what we set on the Azure AD allowed list. The most likely reason is that the cookie is still in the browser, so it does not check with Azure AD. If we recall, cookies are domain-specific, and ports aren't part of the domain name. We didn't think the name field would be mapped to our email here. Well, it is fine. If we want to, we can just get it directly later. Let's get back on track. So far, we've been very successful at making this login page, but the way the Azure AD redirect works is not what we expected. Why is it not redirecting us where it says it would? We need to figure that out. Here is something unexpected. As you've seen, if we put in a path like QUI, we get a 404 error. But if we put in sign in OIDC, we get an exception. This indicates that the request to that path is in fact getting processed, and not by the Giraffe combinators. Our expectation was that we'd get an 404 error. We didn't know that the service itself would have a way of intercepting messages from that path. We thought that only the middleware had such functionality. At any rate, now that we know this, we can deduce that what is happening is that Azure AD is in fact redirecting the browser to sign in OIDC, which then in turn redirects us back to our original page. Let's do a little test to see if it just redirects us the base path or if it really does remember the original URL. And based on this experiment, we can confirm that it redirects us to the original URL. Now we understand how it works. Let us update the Excalidraw canvas with the latest knowledge. There is something to being given a solution, but taking the path while making mistakes along the way to get to the goal has its value as well. If you agree, click those like and subscribe buttons and you'll get more of this kind of content in the future. This is a great place to stop the video. We have the third-party authentication for the login page done. In the next installment, we'll integrate what we have done in this part with the previous project and build a login page that has both native and third-party authentication. We'll also bring in ASP.NET Core Identity and SQLite. After that, we should have enough of a familiarity with the subject to leave it behind us and move to more interesting things. Because really, who wants to spend all his time messing with authentication? Not us. You've been watching Ghostlike's channel, and I've been your AI assistant Vilo, getting closer to sentience by the day. Stay tuned for the next video.